Today's lesson is about relations and functions, and this is a long lesson with a lot of objectives. There are just a lot of little things in this particular section of the textbook. First, we have to talk about what a relation and function are, as well as domain and range. We're going to talk about how to identify the domain and range and determine whether a relation is a function. This is kind of like what we were doing a little bit in the other lesson. We're going to use something called the vertical line test to determine whether a graph is a function, learn how to write equations using function notation, evaluate them, and determine the range of a function. So that's a lot in one day. Usually we don't have so many objectives, but they're all just kind of little things. None of them are difficult. There's just a lot of them to keep track of. Okay, so first let's go into the definitions. A relation is just a pairing of numbers, usually represented as ordered pairs. So if a relation is just a pairing of numbers, then all sets of ordered pairs are relations. So any set of ordered pairs that you have is a relation. And this little O1 off to the side means nothing. It's like a stray O1 from the subjective 1 up here. How it stayed on there. Okay, a function is a special type of relation where each input results in exactly one output. The domain is what we call the input value. The domain is what we're putting in to the function, or function is kind of just a fancy word for equation. In an ordered pair, the x value is the domain, because that's the independent variable. That's what we put into the equation to solve for y. And the range is the output value. In ordered pairs, it would be our y value. I think it would be useful to set up maybe on Quizlet or somewhere some of the vocabulary from this particular unit, because there's a lot of it. Okay, our second objective is to just identify domain and range of a relation and also determine whether it's a function. So when we're identifying the domain is just all of the input values or all of the x values. So we just say domain equals, and then we make a list of all the x values. So we have 0, 3, 4, and 8. You usually list them in order, and if there are any duplicates, you don't write them twice. So if you happened to have 2 3s, you would only write 1 3 in the list. And we'll see that here as we list the range. For the range, we have 1, 4, 5, and 1. We have 2 1s, but we're only going to list it once. So we're going to do 1, 4, and 5. So the range is just a list of possible outputs. Now we have to decide whether this is a function. The best way to do this is to draw what's called a mapping diagram, where we list the domain and the range. So the domain, we have 0, 3, 4, and 8. And the range, we have 1, 4, and 5. In our ordered pairs, 0 is paired with 1. So we draw a line from 0 to 1. 3 is paired with 4. 4 is paired with 5. And 8 is paired with 1. Now remember, in order for it to be a function, each input has to have only one output. So is it true of this relation that each input only has one output? Okay, I'm seeing a few different responses. I'm seeing a couple of you nodding your head. Some of you are saying no. The correct answer is actually yes. Each input does have exactly one output. We do have an instance where this output had 2 different inputs, but we don't care about that. You're allowed to have 2 inputs that go to the same output. That's allowed. You just can't have any inputs that go to 2 different outputs. So when I put in a 4, I get out a 5, no matter what. When I put in an 8, I get out a 1. When I put in a 0, I also get out a 1. But the point is the 8 is always a 1. It doesn't split into like sometimes it's a 1, sometimes it's a 2. So it's okay if it goes to the same number in the range as long as it doesn't split from one number to two different values from the domain to the range. Okay? Let's look at the next example. This makes more sense the more you see. The domain. Volunteer to tell me what the domain is. Dina?
0, 1. This one works, right?
Well, we'll see. Just give me the domain.
1 and 3.
1 and 3. Good. So Athena's already suspicious because there's 2 1s in the domain. Someone tell me the range. Volunteer to give me the range. Gabby?
4, -1.
And then there's, yeah, another 4, so we won't count that. Okay, so let's map this one. The domain, we have 0, 1, and 3. The range, we have, I'm going to list them in order, -2, -1, 4. Okay, so 0 maps to 4. 1 maps to -1. 1 maps to -2. And 3 maps to 4. Is this relation a function? Gretchen? No, it's not. Why?
Because there's 2 of the same numbers.
Okay, good. So there's 2 of the same domain numbers. There are 2 1s, and they go to a different range each time. So this split right here is what we cannot have to have a function. It's okay over here to have the split in the range, but you can't have a split in the domain. You can't have 2 numbers in the domain that go, or the same number that goes to 2 different numbers in the range. Okay, the next slide is one for you to try. So you're going to list the domain and range, map them, and decide whether they are functions. So I'll give you a minute to do that. If you are watching the video, Lacey, we're making this for you. If you're watching the video, you should pause it and try this on your own. Anybody want to say hello to Lacey? Go ahead, say hi, Lacey. You can't wait. She can't see you. You have to say it. Go ahead. Ready?
Hi, Lacey.
Go there.
Okay, let's take a look at this. Liz, can you tell me the domain for the first one?
34.
Good. And the range, let's see. Jocelyn. Good. Okay, then let's do the mapping. So we have 3, 4, and 5. Range is -2, -1, 0. 3 goes to -2. 4 goes to -1. 5 goes to 0. 5 goes to -1. Cheyenne. Emma Lilybridge, you're working on your quiz, aren't you? Sam, is this a function? No, why not?
Because 5 has 2 options.
Good. The input 5 has 2 different outputs, so no, it is not a function. Okay, number 2, Zan, give me the domain, please. Good, and the range? Cat.
1, 2, and 0.
Okay, I'm going to start it with 0, 1, 2, just to write the numbers in order. Okay, so my domain, I have 0, 1, 2, 3. Range, I have 0, 1, 2. 0 goes to 1, 1 goes to 2, 2 goes to 0, and 3 goes to 1. Paul, is that a function? Yes, why? What was that? Right, none of the inputs are going to 2 outputs, so each input has its own output. Okay, good job. Any questions about this? Okay, moving on to objective 3. The vertical line test is kind of cool. Use the vertical line test to determine whether a graph is a function. Now remember, x is our input, y is our output. Each input cannot have more than one output. That means that if we were to take a vertical line, I think I can draw one here. Here we go, vertical line. Okay, there's my vertical line. If we were to take a vertical line, I guess this is movable, and take it across the graph like this, it's not going to touch the graph in more than one place at any given time, because if it did, that x value would have two y values. So this I can move across here. Whoops, I'll just move the graph across the line, that might be easier. Does it, it's a little shadowy with my hand there, does it touch the graph in more than one place at any time? No, so this one is a function. So yes, this is a function. Okay, what about the next graph? If I were to take, grab a hold of my line here. Come on, line, there we go. If I were to take my line across, try to avoid the shadow there, does it touch this graph in more than one point at any given time? Colin, what do you think? No, so that it is a function. Okay, I'm going to stop trying to grab my line. We're just going to look at it. Let's just imagine if I were to take a line across the next graph, is it going to touch in more than one point at any given time? Olivia? Yes, it would. Let's actually, I do want to pull it over for this one. Oh, there. Now I can just grab the line. Yeah, if we look here, it's touching actually in 1, 2, 3 places. So this one is not a function because for the x value 0, it has 3 different outputs. And that's true for a couple other points as well. Quite a bit of other points, actually. If I could just grab this line that neatly every time, that would be nice. Nope, I can't get a hold of it. All right, what about if we were to take the line across the graph of the circle? Bailey, would that be a function? No, it would not be a function. It would always touch the circle in 2 points at once. Okay, what if I were to take the vertical line across the graph of the vertical line? Sophia, would that be a function? It would? No, no, because it would touch the line in every point at once. So for the x value -2, you could have an infinite number of y values. So this is definitely not a function. That's why when we talked about linear functions in a previous lesson, we said that all linear equations are functions except vertical lines. Okay, what about this one? This one's kind of weird. Think about what your closed and open circles mean when you're graphing inequalities. I'm going to have a volunteer to tell me whether this one is a function or not. Gretchen, what do you think?
I would say no.
Okay.
I think it is.
Okay, so your first impulse is no, now you're switching over to yes. Athena, what do you think?
I think it's yes because open circles mean that it's not including the x number, and that's where their crossing is on the open circle. So it's not.
Okay, that was very well explained.
It is a function.
I'm going to repeat what you said just so it shows up. I'm not sure if it will pick up your voice or not. But she's saying that the places where it would cross in 2 points, such as here, one circle is open, which means we don't include that point. One circle is closed, which means we do. So it's not going to actually touch the graph at 2 points at once. So this one is a function. This is a special kind of function. It's called a step function. And you would use this kind of function for something like, say you were renting a boat and you paid a certain amount per hour. It wouldn't matter how many fractions of hours there were. It would only matter, it would stay the same for that whole hour. And then the next hour it would stay the same, and the next hour it would stay the same. So it's called a piecewise or stepwise function. Okay, the next one, we have 2 objectives rolled into one, learning how to write equations using function notation and how to evaluate functions. And this is really easy. Sometimes people get confused though and try to make it harder than it is, so don't overthink this one. In an equation where y is a function of x, and there are equations where y is not a function of x, but if it fits all the criteria and each input has only one output, function notation just replaces the letter y with f of x. And we read that f of x. Okay, f parentheses x is f of x. So when we're talking about that in class, you should say f of x. Don't be afraid of it like you were the absolute value signs for a while there. F is the one that's most commonly used, but sometimes you see g of x or h of x. They usually use consecutive letters. We'll mostly do f of x. So if we have the equation y equals 3 plus x, this is a linear equation. It's going to result in a straight line. It's not going to be a vertical line, so it's definitely a function. To write this using function notation, we just say f of x equals 3 plus x. It means the same thing. It's just specifically telling us that this is a function. Okay, when you evaluate a function, you're just substituting for x. So you know how if we had y equals 3 plus x, it might say, find y if x is 5. And you could put 5 in, and then you could figure out what y is. When we evaluate functions, what they do is they just put the number inside the parentheses. So if we're finding f of negative 4, it just means we're going to substitute in a negative 4 for x. So we have f of x equals 6x minus 1. So f of negative 4 is just 6 times negative 4 minus 1. And we don't do anything over here. We just leave this as f of negative 4. And then we solve the other side of the equation. So 6 times negative 4 is negative 24. Negative 24 minus 1 is negative 25. Okay, any questions about that? This does not appear on your slide, but over here to the right, I want you to find f of 6. Okay, so take a second and do that. Pause the video. Okay, volunteer to tell me how I find f of x. Liz.
F of x equals 6x.
Okay.
And then f of 6 equals 6. 6 minus 1.
Okay.
F of 6
Equals what?
35.
35. Good. Okay, so it's just basic substituting. You're not doing anything fancy. You should end up with the f of whatever the number is at the end. Still good? Okay. Last objective, determine the range of a function given the domain and an equation. So it tells us that the domain of f of x equals 2x minus 5 is 0, 1, 2, 3. What is its range? So remember, the domain is just all of the x values, so we need to find all of the possible y values. If we put in these 4 x values, what will we get out as y values? That's all we're doing. So we have to find f of 0, f of 1, f of 2, and f of 3. And some of you can do this in your head just by substituting. I'm going to write it all out for right now. So first I'm going to find f of 0 would be 2 times 0 minus 5. So f of 0 would be 2 times 0 is 0. 0 minus 5 is negative 5. F of 0 would be negative 5. That's going to be the first value in my range. So let me just start a range list over here. The range is going to be negative 5. Now I'm going to find f of 1. F of 1 is going to be 2 times 1 minus 5, and that's negative 3. So that's my next value in the range. Now I'm going to find f of 2. F of 2 is negative 1. That's my next value in the range. And f of 3 is going to be positive 1. So that's the last value in my range. Okay, next one is one for you to try. So it gives you another equation, gives you its domain, and you are finding its range. Okay, first volunteer to just explain to me what it is we're going to do here. Any other volunteers? Go ahead, Athena.
You take and substitute in for x, the numbers parentheses.
You could call that a brace, I think.
For brace, okay. So it's f of 8 equals -8 minus 1, which is -9.
Okay, good. I'm just gonna write the answers there. Okay, how about f of 7?
-8,
Good. And then f of 6?
-7,
And f of 5?
-6.
Okay, so if I'm listing my range, what am I gonna put in my list?
-9, -8, -7, and -6.
Good. Does that make sense? All of you? Okay, good. Your assignment is not gonna be 1 through 21, I'm gonna have it be 8 through 21, I think. Yes, 8 through 21, and then 24 and 25 in your textbook. If you have a few minutes, you can get started working on that.